Hey everyone, welcome to this explainer. If you've been tracking the explosive growth of tech lately, you know we're absolutely drowning in buzzwords right now. Machine learning, deep learning, generative AI, neural networks. Honestly, it can feel like a totally overwhelming alphabet soup. But what if I told you that all of these terms aren't just random, disconnected technologies? They actually form a brilliant, incredibly logical structure. So today, our goal is to demystify the whole thing by climbing the evolutionary stack of artificial intelligence, starting from the absolute bedrock and making our way all the way up to the bleeding edge.
Okay, let's dive right in. The magical, mind-bending AI we see today doesn't just exist in a vacuum. It is actually just the top layer of a massive six-layer foundation meticulously stacked on top of decades of computer science. From the foundations to the future, every single layer powers the intelligence right above it. And we're going to climb this mountain together. So here's our roadmap. We'll start with the broad foundations, move into mimicking the brain, explore deep learning hierarchies, enter the generative AI era, and finally look to the future with agentic AI. All right, starting off with section 1, the broad foundations. Let's start right at the base of our tower, looking at layers 6 and 5 to see exactly where this whole thing kicked off. Down at layer 6, we have artificial intelligence. This is the overarching concept that birthed the entire industry, dating literally all the way back to a 1956 summer workshop at Dartmouth College. Way before we had chatbots or image generators, there was just this massive, ambitious goal, building intelligent systems that solve problems. To actually achieve that goal, those early computer scientists broke AI down into 5 core pillars. We're talking reasoning, natural language processing, knowledge representation, planning, and expert systems. These were our very first attempts to make machines solve problems logically. Think of expert systems as massive digital rulebooks. We essentially tried to hard-code human logic into a computer, teaching it to navigate situations with strict if this, then that reasoning. It was completely foundational, but as you can imagine, it had some pretty strict computational limits. And that limitation brings us up a step to layer 5, machine learning. Guys, this represents a massive evolutionary shift in the timeline. Instead of programmers agonizingly hard-coding every single rule and behavior, we developed algorithms that actually learn patterns and make decisions from data. This is the exact layer that birthed the recommendation algorithms curating your internet feeds today. The machine basically started writing its own rules based on the information it was fed. How did they pull that off? Well, by relying on some very specific statistical tools. We used regression for predicting numbers, classification for sorting things into distinct buckets, and anomaly detection for catching things like credit card fraud. Add in dimensionality reduction and clustering for grouping massive data sets together, and suddenly, these techniques allowed machines to finally start categorizing and predicting data on their own. It completely changed the trajectory of computer science. But, as data sets grew exponentially, we needed fundamentally better ways to process them. Moving right along to section 2, mimicking the brain. Welcome to layer 4, neural networks. Now, what's really fascinating here is the shift toward direct biological inspiration. Scientists realized that to achieve greater intelligence, we needed an architecture that mirrored how our own neurons fire and connect in the human brain. We kind of moved away from pure statistics and looked directly at biology. To make that biological leap, we started with perceptrons, which are the simplest artificial neurons. Fun fact, the earliest perceptrons in the late 1950s weren't just lines of software code. They were massive physical machines with crazy tangles of actual physical wires. We layer these together to create multilayer perceptrons, or MLPs. Then we developed backpropagation, which is this brilliant mathematical method that lets the network learn from its mistakes and actually adjust itself. From there, we specialized. We built CNNs to process images and RNNs to process sequences of data over time. Think of these as the digital synapses and pathways allowing for way more complex computation. And with those brain-like structures in place, we were finally ready to scale up. Which brings us to section 3, deep learning hierarchies. All right, layer 3, deep learning. We hear this term constantly, right? But what does deep actually mean? It literally just refers to the sheer number of hidden layers stacked between the input and the output. By stacking those earlier neural networks into massive multi-layered hierarchies, the machine can learn incredibly complex, non-linear representations from data. It's like a giant puzzle. It can look at a picture, use one layer to find the edges, use the next layer to find the shapes, and use an even deeper layer to recognize a highly specific face. This layer gave us some absolute heavy hitter architectures. We've got LSTMs for remembering long sequences of data, GANs, which are super cool because they literally compete against each other to improve, GNNs, and autoencoders. But the absolute game changer here, transformers. Introduced back in 2017, this specific architecture gave machines the power to understand sequence, context, and structure in a truly revolutionary way. It completely set the stage for everything that comes next.
That sets us up perfectly for Section 4, the generative AI era. We are now stepping right into the territory of modern breakthroughs. Layer 2 is generative AI. See, up until this point, layers 6 through 3 were primarily about analyzing data. They categorized, they predicted, they recognized patterns from the past. Generative AI is where the machine stops just analyzing past data and starts actually creating entirely new things. It creates new content, new ideas, new solutions. This is just a massive, unmistakable evolutionary upgrade for artificial intelligence.
And the tools powering this creation are incredible. We have large language models, or LLMs, generating the text we read, which are heavily powered by those transformers carrying over from the deep learning layer. We have diffusion models, which are absolutely mind-blowing because they can generate breathtaking, high-fidelity digital art out of pure static noise. And we're rapidly moving toward multimodal models, systems that can handle text, images, and audio all at once. When you use your favorite AI chatbot or image generator today, you are surfing right on top of this layer 2, which is firmly supported by the deep neural networks and machine learning bedrock right beneath it.
And finally, Section 5, the future, agentic AI. We have officially arrived at the absolute peak of the AI stack, the very bleeding edge of tech right now. And here is the truly vital difference between where we are and where we are immediately going. Generative AI creates, sure, but it's passive. It still sits there waiting for you to give it a prompt. Agentic AI, on the other hand, reasons, plans, and acts completely independently. It represents this crucial leap from passive generation to active, autonomous problem solving. So here we are at Layer 1, agentic AI. This is AI that can reason, plan, and act independently to achieve broad goals. You don't just ask it to write a paragraph. You give it a complex objective like, hey, organize my schedule and book my flights, and it figures out the whole shebang. It doesn't just wait for a human prompt. It takes calculated, reasoned action.
Let's walk through exactly how an autonomous agent actually pulls this off, step by step. First, it uses memory to recall past interactions and context. Second, it utilizes planning to strategize a way forward. Third is goal decomposition, taking a massive, complex objective and slicing it up into bite-sized tasks. Fourth, tool use. It's actually reaching out to the internet, calculators, or calendars to get the job done. And finally, autonomous execution. It strings it all together and solves the problem entirely without human intervention, hopefully without accidentally booking you a one-way ticket to Antarctica by mistake. It really is the absolute pinnacle of the AI stack.
So we've climbed from the broad, early foundations of artificial intelligence up through machine learning and neural networks, deep into generative models, all the way up to autonomous agentic AI. You've seen the blueprint, and you've seen how every single layer powers the one right above it. So I want to leave you with this final thought. If this continuous stack of building blocks has already brought us to machines that can act and plan completely independently, what is Layer 0 going to look like? I'll let you ponder that. Thanks so much for joining me on this explainer, and keep exploring.